right now, somewhere in the United States government, there is software running our critical infrastructure that was actually built on code written before the invention of the iPhone.
Oh, easily. I mean, probably before the iPod, honestly.
Right. And, we tend to picture these massive federal agencies just sort of drowning in red tape, running on ancient, dusty servers.
Which is a stereotype for a reason.
Totally. But tomorrow,
Mhm.
the Department of Transportation is officially taking a massive, really aggressive step to replace all that sprawling legacy tech with, like, autonomous AI, automated security, and shared cloud platforms.
Yeah.
So welcome to our deep dive.
It's just a remarkable pivot. We're looking at a stack of incredibly detailed government procurement documents today.
Yeah, and they're pretty heavy reading.
Very much so.
Yeah.
Specifically, we have a special notice amendment outlining this overarching strategy called Destinations Digital, and then an RFI, a request for information for a contract vehicle known as 1DOT Digital Services.
And before your eyes glaze over at the phrase government procurement documents, let me promise you this is anything but dry paperwork.
No, it's actually really revealing.
Yeah, it's this fascinating, completely unvarnished look at the exact tools, the grand architectures, and, frankly, the really intense high-pressure tests the U.S. government is actively using to modernize the digital nervous system of our transportation sector.
Absolutely.
And as a fun little Easter egg for you, the deadline for the tech industry to actually respond to this massive 1DOT RFI, it's literally tomorrow, July 23, 2026.
Which makes the timing of this incredibly relevant. I mean, the government is effectively going to the private sector and just laying all their cards on the table.
Yeah, like, here's our mess, please help.
Exactly. They are showing their messy reality,
Yep.
outlining this highly ambitious vision, and asking the tech industry to, draw the blueprint to bridge that gap.
Okay, let's unpack this. Because to understand where the Department of Transportation, the DOT, is heading, we first have to fully grasp the overwhelming, honestly, slightly terrifying reality of where they are right now.
It is a lot to take in.
It really is. The Destinations Digital document lays this out in stark detail, particularly in this one section called Table 1.
Yeah, Table 1. It is essentially a catalog of the current technologies in use across the entire department.
Yeah.
And the sheer sprawl of it is just staggering.
It's huge.
Right now, they are supporting a suite of approximately 130 active, completely distinct applications.
130 separate apps.
Yeah.
I was looking at the list of requested tech in this table, and it reads like an archaeological dig of software history.
That's a good way to put it.
Right. Because on one hand, you have incredibly modern tools, things like AWS Cloud Services, Azure, Kubernetes.
The standard modern stack.
Exactly. But right alongside them, supporting massive parts of the agency, you have legacy tech that legitimately made my jaw drop. I'm talking Cold Fusion, MS Visual Fox Pro, Paradox DB.
Yeah, seeing Paradox DB still in active government use is certainly a reality check.
I didn't even know you could still run that.
Well, you have a vast spectrum of technology spanning multiple decades, written by completely different generations of developers, and it's all somehow running simultaneously to keep the agency functioning.
I was trying to picture what managing that actually feels like. It's like walking into a massive, sprawling garage where for, 30 years, people have just been throwing random, highly specific tools into different corners.
Just piling them up.
Right. Or actually, it's like a restaurant where every single chef uses their own custom-forged, completely unique knives and pans, and they outright refuse to share.
That's a great analogy.
And now the government is basically trying to turn that chaos into a highly efficient, standardized commercial kitchen.
Well, that analogy really hits the core of the Destinations Digital vision. The document explicitly outlines their strategy to shift away from that custom knife approach.
Meaning they want to stop doing custom builds for everything.
Exactly. They want to stop relying on bespoke, custom software development for every new problem that pops up. Instead, they are moving toward shared services, FedRAMP-certified cloud environments, and a much narrower, strictly controlled set of technology stacks.
Which makes total sense from, like, an efficiency and taxpayer dollar standpoint.
Yeah.
But looking at the strategy, it seems there's a much more urgent operational reason they need to clean out this garage.
What's fascinating here is that the primary driver for rationalizing this IT portfolio isn't just about saving money.
Really?
I mean, yes, the document does emphasize maximizing the value of IT spend. That's always a factor. But the critical underlying motivation is reducing their cyber attack plan.
Okay, let's break that down for a second. The cyber attack plane essentially refers to how many open windows and doors a hacker could potentially sneak through, right?
Yeah, but to take that a step further, it's not just the sheer number of windows and doors. It's the different types of locks on every single one.
Oh, I see.
Every custom application, every outdated database like that Paradox DB we mentioned, every unique server setup. That is a distinct potential vulnerability.
So they all have to be guarded differently.
Exactly. When an agency maintains 130 disjointed applications built on a dozen different platforms across 30 years of coding languages, patching and securing all of that is a logistical nightmare. You have to monitor completely different threat landscapes simultaneously.
So if they move to a centralized FedRAMP certified cloud, which basically means a cloud environment that has passed the government's absolute strictest security audits, they can defend one very large, incredibly thick wall rather than 130 flimsy, scattered fences.
That is exactly the goal. By narrowing the tech stack and using centrally provided enterprise IT shared services, they drastically shrink the number of targets they have to defend, and then they can focus their cybersecurity resources much more effectively.
So knowing that a single massive agency can't untangle a 30-year knot of 130 legacy apps entirely on its own, the DoT obviously had to look outward.
Right. They need help.
But you can't just put out a generic help wanted ad for something this complex. You have to ask the private sector for a very specific kind of blueprint.
Which brings us to the second source we are darting into today, the request for information for one DoT Digital Services.
Right.
And it's worth noting, this was previously called SWES 2.0 Software Engineering Services, but the rebranding to One DoT really emphasizes their new, unified, single-agency approach.
I was looking at the structure of this request, and they are setting it up as a blanket purchase agreement, or a BPA, and they divide it into two pools, right? A small business pool and an unrestricted pool.
Yes, which is a very intentional structure.
Which seems like a smart way to cast a wide net for talent, making sure they get the massive tech giants, but also the specialized boutique firms. But what I found really revealing is how they categorize the apps these vendors will actually be building. There are 3 distinct scales.
Right. The RFI breaks the ecosystem down into enterprise scale, which are those shared services used by absolutely everyone across the agency.
Okay, like email or basic HR systems.
Exactly. Then there's cross-modal scale, which are platforms supporting multiple different administrations within the DoT. And finally, modal level, which are the highly specific tools for a single program or mission.
And to figure out how to build all of this, the DoT basically gave the vendors 21 different task areas to review. Everything from agile delivery to GIS mapping to AI.
It's a very comprehensive list.
They basically handed the tech industry this huge list and asked, hey, did we miss anything? Are any of these redundant? How would you actually structure this?
Yeah, it's very collaborative.
Here's where it gets really interesting. It is a surprisingly humble approach.
I completely agree.
Instead of a rigid, top-down mandate written by some committee that might be totally disconnected from modern tech, they are essentially crowdsourcing the architectural strategy from the engineers who build this stuff every single day.
It represents a major maturation in procurement philosophy. They aren't pretending to have all the answers up front. In the RFI, specifically in question 9, they ask vendors a very telling question.
What's that?
They ask, how do you identify common business capabilities and abstract them into reusable, integrated, data-driven solutions?
I do have to push back a little on this idea, though.
Oh, go ahead.
I mean, I understand the appeal of a code once, use often strategy. It sounds great. But is that actually a bureaucratic pipe dream? You're talking about taking wildly different operating administrations, let's say the Federal Highway Administration and the Federal Aviation Administration, and forcing them to use the same underlying software platforms.
Sure.
These are historically siloed groups with completely different missions. For example, if the Highway Administration measures data in miles per hour and aviation measures it in knots, how do you force them into a shared database without just causing absolute chaos?
That is the exact friction point that makes enterprise IT so notoriously difficult. And if we connect this to the bigger picture, abstracting those common capabilities into reusable solutions is the holy grail. But the barrier isn't really the technology itself. The barrier is governance.
You mean the human element, like who
Yeah.
gets to actually make the rules?
The politics of data, essentially.
Yeah.
To make a shared platform work across those multiple administrations you just mentioned, you need intense, often uncomfortable governance over shared requirements, architecture, and most importantly, data standards.
Right, because someone has to compromise.
Exactly. If administration A needs a data field formatted one way and administration B needs it another, there has to be a mechanism to decide who wins without breaking the other's workflow.
That sounds like a nightmare, honestly.
It is. And the DOT explicitly asks vendors in the RFI how they have previously governed shared requirements in cross-modal systems. They absolutely know this is a massive cultural hurdle.
So to enforce that kind of governance and finally build this unified commercial kitchen, the DOT isn't just looking for standard run-of-the-mill coding. They are mandating a completely new technological arsenal.
They really are pushing the envelope.
And reading through this list, I was struck by the tension in what they're asking for. Because first, they are making a massive push for low-code and no-code solutions. The sources specifically highlight platforms like Microsoft Power Platform and Appian.
Yep, the drag-and-drop tools.
Right. So my question is, why would a massive federal agency dealing with highly complex transportation data want to rely on drag-and-drop software?
It really comes down to speed and standardization. When you use a low-code platform like Appian, you aren't writing every line of code from scratch.
Okay.
The platform provides pre-built, pre-secured building blocks. This means you can deploy an application much faster, and because the underlying architecture of those blocks is already standardized, it neatly fits into that destination's digital vision of reducing the custom tech sprawl.
Okay, that makes sense. But then right alongside the low-code push, they're heavily emphasizing AI-augmented software engineering.
Yes, that's a huge component.
They are asking vendors how they use autonomous or semi-autonomous agents for code generation, automated testing, and reducing technical debt. They essentially want AI robots writing code and cleaning up the messy legacy garage for them.
The integration of AI into the actual software development lifecycle is where this RFI becomes genuinely cutting edge.
Right? But here is where the tension lies. In the very next breath, the document dives into some of the strictest cybersecurity and engineering requirements imaginable.
Oh, absolutely. The rigor is intense.
They demand site reliability engineering, or SRE. They talk about managing error budgets, and they put a massive spotlight on software supply chain security. So what does this all mean? How do you balance relying on drag-and-drop platforms and AI agents that we know sometimes hallucinate code with the demand for flawless, airtight engineering rigor?
That tension is literally the central challenge of modern software development. Let's look at how the RFI attempts to solve it, starting with those concepts you mentioned, SRE and error budgets.
Okay, break that down for me.
Site reliability engineering essentially treats operations like a software problem. Instead of having a separate IT team fixing server crashes, the engineers who build the software are actually responsible for its uptime.
Oh, interesting. And what about the error budget?
Think of an error budget as a literal allowance for system failures. Let's say a system must be up 99.9% of the time. That leaves 0.1% of the time, maybe 43 minutes a month, where it's technically allowed to be down.
Right.
That 43 minutes is your error budget. If your AI-generated code pushes an update that causes a 30-minute outage, well, you've spent most of your budget. If you blow past the budget completely, all new feature development freezes.
Wait, really? It just stops?
It stops. You're forced to stop relying on rapid AI generation and spend 100% of your time fixing stability. It's a built-in mathematical guardrail against moving too fast and breaking things.
That is a brilliant way to force accountability. But what about the security of the actual code the AI is writing? The RFI mentions preventing unverified components from entering production, and it requires something called SBM generation.
Yes. The SBOM, the Software Bill of Materials, is arguably the most critical piece of this cybersecurity puzzle. Think of it as a highly detailed nutritional label, but for your software.
A nutritional label. I actually really like that.
It works perfectly.
So it's like if there's a salmonella outbreak with an onion supplier, a commercial kitchen can just check its ingredient list to see if they bought those specific onions rather than throwing out literally everything in the pantry.
That is exactly the right way to look at it. In modern development, nobody writes a massive application entirely from scratch anymore.
Right, they borrow stuff.
Exactly. You pull in open source libraries, cloud services, and now AI-generated snippets. The problem is, if a massive cyber vulnerability is discovered in one tiny open source component, like the Log4j vulnerability that panics the entire tech world a few years ago, you need to know instantly if any of your 130 apps use that compromised onion.
So the SBOM is the paper trail. It tells the DOT exactly what ingredients the AI pulled from the internet to build the app.
Precisely. And this is vital because the ingredients they are asking vendors to use are incredibly complex.
Like what?
Well, Table 3 of the RFI lists tools like Kubernetes and Docker, which are essentially standardized shipping containers for software, so it can run reliably anywhere, alongside TensorFlow for machine learning, AWS cloud services, and even blockchain.
That's a lot of tech to keep track of.
It is. You cannot rely on a human to manually review every line of code involving those tools. The DoT needs the speed of AI development, but the SBOM provides the automated traceability to instantly locate and rip out a vulnerability when one inevitably appears.
Which naturally leads us to the most intense part of this entire blueprint. Because it's one thing for a tech vendor to promise a perfect SBOM and secure AI guardrails on a beautifully designed, like 50-page PDF proposal.
Oh, anyone can write a good proposal.
Right. Anyone can hire a brilliant proposal writer. So how does the DoT actually verify that these companies can do what they claim without getting duped?
By throwing out the traditional resume reading process entirely and putting them through a gauntlet. The RFI dedicates a significant section to evaluation, demonstration, and challenge concepts.
They are essentially setting up live fire exercises.
Yes, exactly.
They propose live environment simulations and real-time architecture exercises. But the one scenario that honestly made me sweat just reading it is the agile mid-sprint pivot scenario.
It is a phenomenal test of real-world operational capability. The DoT proposes simulating a scenario where a vendor is in the middle of active software development, a sprint, and suddenly the government artificially injects a massive disruption.
Just to see what happened.
Exactly. It could be a high-priority legislative change, a new policy mandate, or even an active security threat.
It's structured like a high-stress hackathon. They don't just want to see if the vendor can write code. They want to see how the vendor reprioritizes their entire backlog, manages risk, and crucially, how they communicate with government stakeholders when everything suddenly catches on fire.
Communication is key there, yeah.
And they also propose an AI-augmented engineering scenario to watch live how a vendor uses autonomous agents to generate code. And more importantly, how the human engineers verified that the AI didn't just casually introduce a massive security flaw while everyone was watching.
This raises an important question about the fundamental evolution of government procurement. Historically, the government evaluated technical compliance.
With checking boxes.
Exactly. Can you build the widget exactly as described in paragraph 4? Now, they're evaluating agility, crisis management, and the ability to pivot securely under extreme pressure. Because managing a national transportation infrastructure means the requirements won't wait for a 6-month review committee. They will change overnight.
I do have to wonder, though, and I appreciate that the RFI itself actually brings this up, is this gauntlet totally fair? The document refers to it as the demonstration burden.
Yes, the burden is a real concern.
Because if you force companies to perform live, high-stress hackathons, aren't you going to unintentionally lock out the small businesses? A massive tech conglomerate can afford to pull 10 of their best engineers off billable work for 2 weeks to prep for a free government test.
Right. They have the overhead for that.
But a boutique small business with a brilliant, innovative solution, they might not have the cash flow to survive that kind of unpaid audition.
The DoT is highly aware of that risk, which is why question 28 in the RFI specifically asks the industry for feedback on how to make these live demonstrations fair and practical for small businesses.
It's a delicate tightrope.
It really is. They desperately need the rigorous testing to ensure security, but they absolutely do not want to accidentally create a monopoly where only the 3 biggest players in the industry can even afford to apply.
It's easy to get lost in all the tech acronyms here, but if you've ever flown on a commercial plane, driven across state lines, or relied on the supply chain for your groceries, this level of extreme vetting directly impacts your physical safety.
Oh, absolutely.
The digital infrastructure that governs our airways and highways is being architected right now. This rigorous gauntlet is how the government ensures the tech isn't just shiny and modern, but is genuinely resilient to real-world chaos.
The stakes could not be higher. The transition they are attempting, moving from that fragmented, vulnerable legacy garage of 130 apps to a unified, AI-driven, highly secure ecosystem, is one of the most complex organizational and technical challenges imaginable.
It really is an incredible journey. I mean, we started this deep dive looking at a messy garage running on Paradox BB and early 2000s code.
Feels like a lifetime ago.
And we've traced the blueprint for how the DoT plans to turn that into a unified, low-code AI-augmented powerhouse, all rigorously tested by live-fire mid-sprint crisis simulations.
It is a remarkable glimpse into the future of public sector technology.
Yeah.
But, there is one specific detail buried in the RFI that I think leaves us with a profound question about the reality of that future.
Oh, lay it on me.
In question 16, the DoT asks vendors about the AML product lifecycle, and they specifically ask how a vendor will handle long-term drift detection, fairness, explainability, and risk management.
Drift detection, meaning an AI model that works perfectly and makes accurate decisions on day one might slowly change its behavior over time as it processes new real-world data. It basically drifts away from its original safety parameters.
Exactly. The DoT is explicitly acknowledging that once these autonomous agents are deployed into the wild, they don't just sit static like a piece of 1990s software. They silently, constantly evolve.
Which brings us right back to cleaning out that messy garage. We are throwing out the old predictable tools and replacing them with tools that can think, adapt, and drift.
Which is exciting, but terrifying.
Yeah. So I want to leave you with this to ponder. As our government's most critical infrastructure becomes increasingly reliant on AI models that silently evolve over time, who ultimately holds the accountability when an autonomous agent makes a subtle, unexplainable decision that impacts physical, real-world transportation? Do we blame the AI, the private vendor who originally built it, or the government agency that deployed it? It's a muddy, really complicated landscape, and the blueprint for how we navigate it is being written, well, tomorrow.